Alrighty. Well, here we go. This is Unit 9, Lesson 7.5, which means it's from Chapter 7 in your book, but just how we organize things this time. We're looking at areas of regular polygons. Going to look at numbers 1, 3, 4, 10, 12, 14, 23, 27. All right, so here we go. First of all, to solve these problems here, to find the areas here, we're going to start with learning about the measurements of certain angles. We're going to first look for the central angle here, number 1, and from that what we do after we find the central angle 1 is we look at this line here, which is called the apothem, right? The apothem, and it's going to divide the central angle in two parts. So we'll take number 1, divide it in half to get number 2, and then we'll combine the measurement of number 2 with 90, subtract that from 180 to find out what's left in this triangle to form measurement of angle 3. So what I mean by that is simply this. So let's say, for example, this first one, we have 360 degrees in a shape. This shape has 1, 2, 3, 4, 5, 6, 7, 8 sides in it. So we take 360, we divide that by 8, and we have 45 degrees. That's going to be the measurement of this central angle number 1. The measurement of angle 2 will be 45 degrees divided by 2, because we're going to cut it in half with the apothem. So that means that angle 2 will be 22.5 degrees there. Now to find out what's left for number 3, we take the 90 degrees it's given, and we add to it 22.5, and we know at this point that we've used up 112.5 degrees in the triangle. So to find the measurement of angle 3, we'll do 180 minus 112.5 to figure out what remains. And we're left with 67.5 degrees for the measurement of angle 3. So angle 1 is 45, angle 2 is 22.5, and angle 3 is 67.5. Alright, let's try one more of those because that's going to be something you'll have to do for the rest of these problems as well. Let's look at number 3. Same idea. We're going to go ahead and start with, we have 360 degrees, and we divide it by the number of sides of the shape. It's a pentagon, so 1, 2, 3, 4, 5 sides, sorry. So our central angle number 1 is 72 degrees. That's what's right here. Angle 2, because it's cut in half by the apothem, is half of that. So 72 divided by 2 happens to be 36 degrees. So here's the measurement of angle 1, and here's the measurement of angle 2. Now to find out what's left, once again, we do 90 plus 36. We're at 126 so far, and we'll subtract 126 from 180. And we're left with 54 degrees for the measurement of angle 3. Alright, so we have a 72, a 36, and then a 54. Moving down. Now, in order to find the area of a regular polygon, we have to know the apothem, and we also have to know the perimeter. Our formula is actually area equals the apothem times the perimeter divided by 2. You could also have learned it perhaps in class as 1/2 times the apothem times the perimeter. Either one is fine. They're the same formula, just a different way of thinking about it or looking at it. So I want to look at number 4 first of all as our example. We start off with a pentagon. A pentagon is a shape with 5 sides. They give us the apothem, which is one part of the formula we have to have, but no perimeter. Well, the perimeter is going to be the side length multiplied by the number of sides. So 7.1 times 5 gives us our perimeter for a value of 35.5. Knowing that, I can now use this information and this information to solve my area. My area is going to be equal to 4.9 times 35.5, all divided by 2. When I multiply that out and divide by 2, my area ends up being 86.975. And in this case, these are inches, so inches squared is my area for number 4. When I look at the other ones here, just remember that a hexagon is a six-sided shape. And they just give you the sides each time, so be careful. A nonagon is 9, a dodecagon is 12, octagon is 8, and a decagon is 10. All right, number 10. We're looking now at find the area of a regular polygon where they just give you an exterior side length. And that's okay because we can find the central angle, doing what we did before. And once we find the central angle, well, let's do it first. We do 360 divided by number of sides, 1, 2, 3, 4, 5, 6. We find out that the central angle is 360 divided by 6 is 60. And we're going to cut that in half right there. All right. And by cutting it in half, we're going to form the apothem, which makes this angle right here, half of that is 30. And what's left down here in this space is 60. Okay, so we're doing okay so far. Now let's go ahead and so we can help us out here, we're going to take this shape, this triangle, that space, and we're going to make it bigger right here just so we can look at it. There's my apothem, here's my line down, and here's this line here. Okay, we established that that's 30 and that's 60. Okay, we know that this whole length of the side here is 12. The apothem cuts that in half, so that makes this line equal to 6. Now, this is a special right triangle. It's a 30, 60, 90 triangle. If you remember, we have our short side, our long side, and our hypotenuse. And the way this typically works is that this was our x, this became our x root 3, and this became our 2x when we had our little values before, when we were figuring out special triangles. Maybe you had a root 3, 2a, however you want to look at that here. In this case, they gave our short leg as a value of 6, which means our apothem is going to be equal to 6 root 3. So now I have an apothem. I'm doing pretty well. I also, of course, need to have a perimeter in order to solve the area. The perimeter here is going to be 12 times the number of sides. 12 times 6 sides gives me a value of 72. So now I have a perimeter and I have an apothem, and I can use my formula. Area equals 6 root 3 times 72 divided by 2. Okay, so that's my new formula that I'm working with here to solve this equation. To solve that then, let's go and use the calculator. Okay, work together here. What I'm going to do is I'm going to do 6 times, and I'm going to go ahead and do second and use my square root feature. And let's put the 3 there and close it up with the parentheses and multiply it by 72. And all of that I'm going to divide by 2. And when I do that, I come up with 374.1, and these happen to be inches, oops, not pi, inches squared for my solution for number 10. 374.1 inches squared. All right. We're going to do the same thing for number 12. Number 12, again, it's a hexagon once again, which means my interior angle, my central angle, is also going to be what? It's what we did before. 360 divided by number of sides is 60, and I'm going to cut that in half and make my apothem. So this triangle looks like this. If I make it larger, just so we can see it better, like this. Here's my 30 and my 60. We're going to cut it, instead of 8.6, one length right here will be half of that, of 4.3. This becomes my A root 3, and my 2a. Well, I need to know my apothem value here, so that's going to be, my apothem will be, oh my goodness, I'm way off the page. I'm so sorry. Here, what a disaster that's going to be. Sorry about that. So here's my triangle. Let's back it up here. Okay, to find the central angle, 360 divided by 6 is 60. and then I made my apothem there, and I redrew my triangle. And I have my A root 3, 2A, 30, 60, 90. Half of 8.6 is 4.3. So my apothem value is actually 4.3 times root 3. Okay. My perimeter value is going to be 8.6 times the number of sides, which is 6. And 8.6 times 6 happens to be 51.6. So I have an apothem, I have a perimeter, and now I can use my formula sheet to figure out what that's going to be. So my area is going to be 4.3 root 3 times 51.6, all divided by 2. And when I multiply that out and do all the things I have to do, I'm going to end up with 192.2 feet squared for number 12. Okay? Again, sorry about that over there. I just wanted to help you see that that triangle right here is that one right there. I just want to make it larger so you can see a 30, 60, 90 within it. Okay? On these ones down here, I'm looking at just number 14 first of all. Just don't get too confused by the language. If I drew a hexagon, which we've just done a bunch of hexagons, this is not a very good one. Alright, it says find the measure of the angles formed by 2 consecutive radii, which means find this measurement, okay, and a radius and a side, so this guy, okay. So to find that means basically this is what? This is our central angle, okay, and the second one's going to be whatever's left divided by 2. What I mean by that is this. The hexagon, we said the central angle was 360 divided by 6 was 60, okay. So what's left? Well, what's left is 180 minus 60, or 120. That's what's left between both of those two angles together. I want just one of them, so I'll do 120 divided by 2. And in this case, I end up with 60. So the answer here is 60, 60. It's not quite the same on the other ones, okay? So for example, on an octagon, you have 360 divided by 8, and that gives you a central angle value of 45, okay? So what's left after 45? 180 minus 45. In this case here, we are left with 135. But I got to divide that by 2 for the other number they're looking for. 135 divided by 2 is 67.5 degrees. So my two answers here for the central angle is 45, and one of those base angles for the octagon, right, would be 67.5 degrees. Let's flip it over to the back side for 2 more of these guys here. Number 23 is a good problem. Number 23, we have a triangle, and we have the apothem here at 3.3, and I don't know the length of the sides. Again, so for the area, right, the area says I have to know the apothem times the perimeter divided by 2. Well, I have the apothem. That's great. 3.3. I could plug that in, but I don't know the perimeter. To find the perimeter, I need to find out what this length is going to be. Well, this length, I can do that by finding, again, my central angle. So I cut that like that. It's a triangle, so 360 divided by 3 sides for triangle gives me 120. So this whole angle is 120. Half of that, because the apothem, would be 60. So once again, I have a shape that looks like this and like this. And I have a 60 right there in that space. I have the apothem of 3.3. This is my 30. So my short side is 3.3, which means my long side is 3.3 root 3. Okay? So that's the distance right here. It's 3.3 root 3. So what I want to look at is a whole length here of a triangle. It's 2 of those. So 3.3 times 2 is equal to 6.6. Okay? So I actually have 6.6 as my side length. 6.6 root 3 is the length of one of the sides. Now I'm not done with 6.3 6.6.3 because that's one side, and I want to multiply that by the number of sides in triangle, 3. So I actually have, times 3, I actually have 19.8. 19.8 root 3 is my side length. Now I'm ready to plug things back in. So I have my apothem, 3.3 times 19.8 root 3 divided by 2. That's my area there. Now, it does say, look in directions, leave it in simplest radical form. Okay, so that means I'm going to leave the root 3 alone. So when I go ahead and multiply 3.3 times 19.8 divided by 2, I end up with 32.67 root 3, and that's going to be feet squared as my final answer for number 23. Okay, our last one here, number 27. Working a little backwards this time. It has a stop sign. It says a regular octagon. The side, it says, is 12.6. The area, that's the big A, is 770 inches squared. What is the apothem, little a? So to set this up, I actually have 770, my area, equal to the apothem, I don't know, times the perimeter. Well, I don't actually know the perimeter, but I do know the side length. The side is 12.6 times octagon is 8, and 12.6 times 8 is 100.8. So I do know the perimeter now, divided by 2. So this is my equation to find the area, but in this case, I know the area, I need to find the apothem. So now I'm going to work backwards. So multiply both sides by 2, and I end up with 1540 equals A times 100.8. I divide by both sides by 100.8, and I find out that 15.27 equals my apothem. It does want us to find the nearest whole number, so the nearest whole number is 15. And that's how I solve number 27. All right, hope that helped you out. Have a great day.